Hi, this is Ari Gilner doing a demo for the Broken on Purpose tic-tac-toe page for my Calendly assignment. The tool that I've elected to use is Catalan Studio. That's because it's the tool that I've used most recently and therefore I'm most familiar with. It also uses Groovy as a scripting language, which is fairly straightforward. It's also very good, very good tool for carving up and organizing a automation test project and framework in a way that makes it very digestible and referenceable and usable, and you can build off of it, and it won't become a tangled, spaghettified mess after a while, as long as you keep your naming conventions and your object repository set up properly. So um, I've created 5 test cases. Um, you can see all 5 of them here. One creates a 3x3 game, one creates a 4x4 game, one creates a conventional 3x3 game where O wins, and one where X wins. The last one creates a game where someone wins, um, and then it refreshes, and then it makes sure that you can create a new game after that. Um, the object repository that I've pre-populated to use here is already in place. You can see there's objects here for the play button, for the congratulations dialog boxes, the input numbers, and the various locations of the table grid as they come into existence. I've created the suite here. I won't run through the whole suite because I'll be doing these individually, but I just wanted to show how that's organized. So let me show you the most basic test cases. Some of the reasons that I wanted to use the tool is because it also helps to illustrate some of the more intermediate things that you can do with test case best practices and strategy. For example, the first thing that the 3x3 game test case does is it opens the browser, navigates to a web page. The web page is not hard coded. I've created an execution profile here called tic-tac-toe prod, and I've set what's called a global variable for that, where I have put the value of the URL. There's no reason to do that in this case, but what it does do is it makes all these test cases agnostic in terms of environment. If this tic-tac-toe app were present on a sandbox, on a staging environment, etc., and you wanted to run this suite, all you'd have to do is have a separate execution profile or simply change the base URL and you could run your entire suite. You can also specify this as in a command line when you run the test runner as part of a continuous integration process through a Jenkins job or something like that. So that's also useful. Um, if you have multiple build agents or multiple environments that you're deploying to. So first thing it does is navigates to that page. Next thing it does is verifies that it can find the play button. This is just extra insurance to make sure that we've arrived where we think we have. It's one thing to hit a 404 or a 403 hard error, which the tool will obviously recognize. Since it runs Selenium underneath, it's pretty smart that way. But this just makes sure that we've actually arrived at not only a valid page, but our page. A little extra insurance. So then the next thing that it does is finds the input play number and sets it to 3, hits the play button. Then it makes sure that it can find the first item in what would be a 3x3 grid. Then it can find the last cell in a 3x3 grid. And then it, for further insurance, makes sure that it can't find the last cell in what would be a 4x4 grid. Considering the tool only creates squares, this gives us a good amount of confidence that what the browser is looking at is, in fact, a 3x3 grid. The create 4x4 game is very similar, except we replace 3 with 4, and it looks for the 15, which is the 16th cell, and looks for the last cell in what would be a 5x5. So it sort of ensures that we're looking at what we want to. Let me run these for you, just so you can see them run. These can also be run headless in this tool, so without the browser coming up, but that's no fun. So we'll look at it here. And there it is. These tests do not have a close browser command in them because they will act as dependent test cases for other test cases that build on them. So if they close, they wouldn't do other test cases any good. Let's get rid of these test results here. And let's dive into some of the more functional things. So we'll go into a 3x3 game where O wins. Now, this test case, when it runs, will fail. It will fail because of a bug in the tool, in the app itself. In that when there is a winner, it states that the winner is the opposite of the winner. For example, when O wins, it will say that X won, and vice versa. So this test case is set up with the expectations of what would be proper functioning and therefore will fail when we run it. You'll see that the first thing that it does here, instead of opening a URL, is in fact calls the create 3x3 game. This means that if we've got 15 different test cases that rely on a 3x3 game grid, that we can reference them all here. And if something about the process of creating a 3x3 game fails, changes, anything, we can fix it in one place. It's the same strategies as one uses when you create an object repository and then reference the same object every time, so that if something changes about your play button, it ends up in another container or something like that, and needs some refactoring, the XPath changes a little bit, you can just update it here and everything will start working again. So it executes this, you get your 3x3 grid, then it begins to play. Clicks the first cell, and make sure that, which would put an X in it, make sure that it's an X. Then it's O's turn, it puts an O in the next cell, make sure it's an O. Continues to do it in this way in an order in which would allow O the victory. Then it looks for the congratulations player O dialog box, and then we'll attempt to close the browser. Because the test case fails, it won't close the browser when we run it, but if it were to get to the end, that's what it would do, so it would clean up after itself. So let's go ahead and run it for you guys. And there he goes. There will be a 30-second timeout here that I'm not sure how to fill because I don't do screencasts often. This is my second attempt, actually. The first one went pretty smoothly, but when it uploaded to YouTube, it only uploaded on potato resolution, so it was on 360p. You couldn't actually see any of the text. So hopefully this one will go better. And anytime now, we should get some pretty red text down in the bottom right that will complain to us that it can't find this. Yep, there we are. So, failed, unable to verify the object is present because it's not. Instead, it says congratulations, player X. So that would be an excellent thing to lead us to a defect. The 3x3 game X wins is very, very similar in operation. Calls the 3x3 game, plays the game in a very slightly different way to make sure that X wins. This test case will also fail for the same reason. The last test case that I have, unfortunately, because it depends on somebody winning properly, will also fail, but I wanted to show the power of sort of using these test cases like Lego bricks to create totally useful, legitimate, functional test cases with very little rework or wasted work. So in this case, it calls the 3x3 game, which will in fact call out to our dependencies, and then we'll refresh the page, and then we'll attempt to create another grid and make sure that it's looking at a fresh new game ready to play, and we'll then close the browser. So hopefully that gives a pretty good explanation of the scripts that I've created and how they run. Thanks very much.